going to get started here. My name is Corey Zollinger. I'm the Director of Sustainable Infrastructure Solutions here at Cemex. I am incredibly excited for this afternoon session as I think we're going to bring real solutions to the market for folks who are trying to build homes out of resilient materials, right, that don't burn. And this is really meaningful to people. So the topic is construction solutions for wildfire resiliency. So it's highly focused on what's happened here in Southern California recently. But really this is a topic that applies to almost anywhere in the United States, right? You know, I live in Houston. Last year I had a hurricane go over my house. I don't know, a few years before that, I was gutting homes from Hurricane Harvey and they had all flooded, right? I've got friends' homes who have burned down, homes that have flooded. I mean, you name it, right? We're dealing with this across the United States. And so what we wanted to do today was really focus on actual solutions that you can implement on projects, on homes, and really these solutions are available to you. And so that's what we're going to focus on today. I've got three gentlemen here with me who are going to talk about different solutions that they offer into the market. I've got Frank Gordon. He's Vice President, Strategic Development for BuildBlock. I've got Scott Long. He's the founder, CEO of Nile Built. And Joe Chimenti, who's the Director of Community Development with Emergent Construction. So we're going to turn it over to them. They've got fantastic content where they're going to highlight and educate you on their different solutions and what they've seen in the market. So with that, I'm going to turn it over to them and let them kind of take it from here. Frank, it's all yours.
Well, thank you, Corey, and thank you, everybody, for being here today. Again, my name is Frank Gordon. I am with BuildBlock Building Systems. We are an ICF manufacturer, but we also provide full shell, building shell solutions for the construction industry. We started out initially as just an ICF manufacturer, but we have broadened our scope from there to providing full building solutions. So what I'm going to be talking to you today about is the reasons why we need to look at building resiliently, not just in California, but really across the United States. So some of the pictures I'm going to be showing you here are of some recent natural disasters that have happened in our country. This is actually a picture from Mayfield, Kentucky. If many of you remember, it was going on 3 years ago now that the tornadoes went through Mayfield, Kentucky. Total devastation in that area. This is a picture of the downtown area and what happened there in that sector. This is a picture from Hurricane Helene. This is Western Carolina, Lake Lure. As you can see from the flooding and the devastation and just, you know, the absolute loss of infrastructure was pretty much devastating in that market. This is actually a picture from the Paradise Fires. This is a place that I have actually done some work at. We've actually, with Habitat, have rebuilt a few neighborhoods using insulated concrete forms as the exterior solution on the buildings themselves. And then this one is kind of we call this one of our poster children of the ICF industry. This is a house that actually survived a direct hit of Hurricane Michael back in 2018. So I show you all these because there's a statement I usually like to use when I'm talking about resilient reasons why we should build more resiliently, and that is the stronger the why, the easier the how becomes. I think it bears repeating that we need to have an understanding of why we're needing to build more resiliently now, not just in the immediate aspect of the effects of something as devastating as the Palisade fires, but also in different other types of events that we see in what is going on in our not only our culture around us, but also in the communities that we live in and also across the United States. So we know that our climate is changing. Last 5 years, from 2019 to 2023, the annual average number of billion-dollar disasters has almost tripled compared to what it was between 1980 and 23. The annual average was 8.5 events from 1980 to 1923, but now that has increased to 20.4 events from 2019 to 2023. $244 billion plus disasters from 2003 to 2022, which is an exponential increase of costly weather and climate events that we see. So how do we fix this? How do we start to do things differently to where when these events happen, we have the ability to recover? Well, the first thing that we need to look at is building more resilient facilities, typically when we're looking at ICC 500 storm shelters, and first and foremost in the interest of protecting life around us. Next thing is when we can build multifunction adaptive use type facilities such as schools that have the ability to be community storm shelters, those are key. In fact, the school that you see on the picture here is a school in Bowling Green, Kentucky. Bowling Green, Kentucky is right next to Mayfield, Kentucky. This neighborhood that this school, Jennings Creek, is in, took a direct hit from a tornado, during that outbreak of tornadoes that happened back in 2023. You didn't hear about this one as much because there was such devastation that happened in the Mayfield area. But the neighborhood that was around Jennings Creek was totally decimated. This is an ICF school. All the outside was ICF and all the roof decks were built out of concrete. This school was actually opened the next day as a base of operations for first responders. Had its own power, had its own storm shelter, had the ability to take people in who had lost their homes. But pretty impactful statement when you can say we do have the ability to build structures that can resist the type of struggles that we're seeing in our environment. So beginning with the end again, what are some of the things we need to look at? We can look at building resiliently, but we've also got to take a full building approach when it comes to building resiliently. We need to look at integrated energy efficient systems, things like geothermal heat pumps, ground source HVAC, LED lighting packages, things like Energy Star rated equipment. All these things come into comparison. This is a part of resiliency and sustainability because you have to be able to not only reduce the impact of having to rebuild after a natural disaster, but also what can you do between those times to reduce your energy consumption and your carbon impact that you have on the world around you. So net zero or zero energy ready is really a term that we hear a lot these days. And if you had talked about being a net zero or zero energy facility the last 10, 15 years ago, 20 years ago, it would seem like it was a target that was well out of grasp. But now what we have found is that when you start with a very resilient and energy efficient shell around a building, almost anything is possible. And so where I was showing you the pictures from Bowling Green, Kentucky, they actually have 5 zero energy schools that are online right now and another 7 that are zero energy ready, meaning if they were to add energy generation, whether it be through wind or through a solar array mounted on the roof, they would have the ability to be a zero energy facility. So all that being said, the only way that you can make these things happen is when you have a high performance envelope around these buildings. That's where ICF or insulated concrete forms comes into play because we have one of the most energy efficient structures that you can put on the outside of a building. And what we find is that energy consumption can be reduced sometimes as much as 50 to 60% within an ICF building. And let me say this, and again, thank you for Cemex for the invite and being here, but all these facilities that you're going to hear talked about today would not be possible without concrete. Concrete really is at the heart of the way that these facilities will work and the way that they have the ability to resist the effects of climate change, but also being able to protect the people that occupy these buildings as well. So when we look at ICF, just to give you a quick description of what ICF is a formwork. It's a cast-in-place concrete wall where the formwork winds up staying in place. That formwork becomes the vapor barrier on the outside of these walls. It also is a moisture barrier. The EPS panels that are on the outside of ICF walls are a Class 2 vapor barrier already, so you don't have to go to additional methods to try and stop moisture and air infiltration in that building. It's a very resilient structure. We have case study upon case study of ICF buildings that have took, in some cases, direct hits from tornadic or hurricanic storms and have survived and have protected the tenants and also the occupants of those buildings and the equipment that they have in those buildings. It's a very resilient fire barrier, and this is going to be more poignant to what's going on here in California. So ICF walls start as a minimum of a 3-hour wall. So when you talk about having that sort of fire resiliency, in the midst of situations like what we saw in Palisades, what we've seen in Paradise, what we've seen in so many different of the annual fire events, it becomes very important to look at how can we protect our people and how can we protect the valuables that they have in those buildings better. And right now, the honest answer is concrete is the best way to do that. So this is kind of a picture of what an ICF block looks like. You've got the two layers of foam that are on either side. The webs that you see in the center actually hold those forms together. Becomes a way to place your rebar. But where you see the webs in between the two panels, that's actually where the concrete would be poured after erection of the building. So what you wind up having with ICF is it's a super insulated, energy efficient, resilient structure envelope that's finish attachment ready. And so when I say it's finish attachment ready, you don't have to fur these walls out. You can actually apply your finishes as soon as the wall is finished. You can begin applying finishes, whether it's on the interior or the exterior, directly to the system because it has its own furring system built into it as well. So when we look at sustainability first, we talk about energy modeling. That's a big part of something that we see more and more of your architecture and engineering firms are gravitating toward, to have a better understanding of how these buildings will use energy. And I think it's something that really should be almost mandatory. We should be doing this in every type of structure that we try to build. The embodied carbon payback. Although concrete at one time was considered to have a very high, and you probably heard this in some of the other presentations today, it was considered to have a very high carbon footprint. The concrete industry over the last decade has been able to reduce its carbon footprint by almost 23%. There is no other major material industry that can say that. Now granted, we had a long way to go in the concrete industry, and in my former iteration with the NRMCA, I learned a lot about that, and I learned a lot about why the making of cement created such a high carbon footprint for concrete. But there's so much innovation that has happened in the last decade within the concrete industry that we are very quickly approaching 50% reduction in carbon footprint by 2030, and we have almost no doubt that we're going to be carbon neutral by 2050. So, want to talk about waste. You'll hear this from these guys as well, but one of the things that's a hallmark of our system is it's very little waste. If you've ever driven by a wood-framed home being built and seen the pile of wood outside as it continues to grow as those walls go up, you'll realize very quickly that it's a very high waste-producing way to build. With our ICF system, typically most of our installers that do ICF walls have a waste factor of between 3 and 5%. That's basically less than half of what most builders have as a waste factor when they're building. And I'd be remiss if I didn't mention everything within an ICF wall is also recyclable. The EPS is recycled. The polypropylene webs are recycled as well. In fact, our polypropylene webs already have recycled content in them. Concrete can actually be ground up and used as new aggregate in new ready mix, and also the steel can be recycled as well into new rebar. Complete code adoption in the ICF industry with the IBC and the IRC. All the testing accepted, UL ratings, everything is completely compliant with the building code. And we are also very thankful to be able to say that FEMA endorses ICF construction as a way to do storm shelters. In fact, I've done several storm shelters on the Gulf Coast out of ICF, and FEMA is a huge supporter of that type of construction. So ICF is a very quick installation. It reduces construction schedules. In fact, sometimes we see construction schedules get reduced as much as 20 to 25%. It reduces worker fatigue. You have minimal heavy equipment, and you have a very efficient design. So as I said, our waste factor is typically awfully low compared to others. It's a superior weather protection on the outside. It's a system versus a unit. If you don't hear anything else I say today, ICF is a system. It's a building system. A lot of lead points can be gained by building with ICF, and the energy demands are much more predictable when you have such a resilient structure that you're existing in. So that is it for my presentation on ICF. So hope I didn't rush through there too quickly, but we will have some Q&A at the end. Scott?
Good afternoon, everybody. We're kind of post-lunch. Is everybody awake? Come on, come on. I'm feeling it too. Okay, so what I'm going to talk about a little bit, it's a little bit different than the whole sustainability discussion. It's really about what we're doing, our firm is doing for really kind of pushing the state of California from wood frame construction to advanced materials. So we take a very, I say, policy, political, kind of code-based approach to technology solution, and then really how are we going to scale this throughout the state. And, you know, right along the path of our business in the middle of doing this, the fires hit last January. We're looking at 16,000 structures between the two fire zones, between Altadena and Pacific Palisades, about 12,000 homes lost, roughly 6,000 in each market. And one of the primary issues that people are facing today is making that decision if they're going to rebuild back with wood and deal with the types of risks that they've already endured in their lives. And the other is, you know, be covering it as we go through, is really just the drivers that are pushing consumers' decision towards more sustainable rebuilds. One of those, and most importantly, being insurance. That's really driving the marketplace for how it's really pushing people to make better decisions, more resilient decisions in their builds. So there's just as kind of a quick product introduction. So our background in this, just to kind of, for frame of reference of what we do, we build, we license technology to build insulated wall panel systems. So picture a 4-inch extruded insulation core wrapped by only 2 inches of macrofiber reinforced concrete on both sides. The images that you see on the bottom right of the screen is the first product iteration, which was created by my father back in 1980. And it was a way to insulate concrete that's not only used in like factory production, site tilt cast, or site cast tilt up, modular prison production, etc. And it really was an innovation that came out of the plastics pultrusion fiber composite business. That business was launched in 1980 as the leading building insulation system for concrete construction globally. Things like Home Depot, NASA, Guantanamo Bay, every winery, distribution center I can think of, Dole Foods, Rikers Island Prison have been built with this. What we then did is took that technology and brought it to the residential sector. So in the commercial and industrial space, it's typically factory produced, it's heavily steel reinforced, it requires large tonnage cranes, it requires a really large expense to be able to assemble these components. Therefore, they're typically used in commercial and industrial applications. What we did is work to downsize all of that. Get rid of the factory, get rid of the cranes, get rid of all of the commercial and industrial aspects of the product. And that was done by, on a technology standpoint, what you see here in the center are called macrofibers. That's the reinforcing matrix that holds the entire wall system together. So by doing this, we've reduced the weight of the product by about 50%. We've increased the thermal performance by 50%. And most importantly, as you see in the illustration to the right, we can produce it on the actual job site. So we get rid of the factory, we get rid of logistics, trucking, the whole 9 yards. The benefit to this is, and this showing a casting sequence, is the panels themselves are produced on the building slab and or an additional waste slab on site. So it's as simple as forming up the dimensions, pouring the first layer of concrete, insulating, putting in the connection system, pouring the second layer of concrete, and finishing it. So what we've done there is take about 15 steps from a wood frame wall that goes up, has to be insulated, drywalled, vapor barriered, stuccoed, all the steps that are associated with that, and we've turned it into one quick step. So the benefit to this for us and for basically in the rebuilds is this is a very scalable process. So we are licensing builders to be able to learn how to use this technology, and they're therefore then connecting with consumers in this particular market to begin rebuilding homes instead of stick framing them on the slab and tipping up the framed wall. You're forming and casting the wall panel itself and tipping it up. You'll see in this photo here, those are the demolded or stripped parts. The bottom left are the parts in place. The center lower photo are the panel elements in place, along with a steel and concrete decking system that we use for both floors and roofs. This creates an entire fire stop on the structure, walls, floors, and roof systems as well. So what we have then is an entirely non-combustible system that is also net zero energy ready because of the thermal core that's inside the product itself. So in the supply interest in aesthetic of the homes, we really started off launching a very modern style home with a flat roof, which you'll see up in the top right. The mission-style homes are very popular in the Altadena, Pasadena market. It's a very historic kind of neighborhood. And then you have the more traditional production-built kind of image that you see in the bottom right. So there's really no design limitations or structural limitations to the homes. Since we launched this a little over 3 years ago, no, a little over 2.5 years ago, we've got over 3,800 clients lined up for these homes in Southern California. That was before the fires started. So there is a big demand in this market for resiliency and sustainable builds. I think there's a big market in this particular part of the country for advanced materials because of the types of disaster events that we deal with here, both seismic and fire related. And there's a growing interest with it. And what we found that's really fascinating in the fire rebuild markets is just how well the public has done educating themselves and understanding the difference between just going back and building with wood or looking at more advanced construction materials. So we have kind of a multi-agency approach that we're taking in the LA fire rebuild area. And this is important because this is the area where I hear a lot of product manufacturers talk about their specific product for a specific application. The problem is, in this particular case, you've got 12,000 applications that have to happen just for this rebuild to take place. The state is currently in need of 180,000 annual housing starts. We hit, I think, about 45,000 this year and declining. The reason it's declining is because with the fire map redistricting that's happened throughout the state and the subsequent fires, insurance companies have pulled back. So we're finding that there's a lot of land that has been developed and entitled and been ready for construction that is now sitting idle because either the HOA cannot get insurance or the consumer themselves cannot get insurance. Bottom line is no insurance equals no mortgage. If that happens, there's no housing industry in behind it. So we've taken a very proactive approach. We're working directly with the governor's office and their GoBiz, the California Insurance Commissioner's office. We're working with major insurance carriers who are endorsing and backing these homes. We're working with the fire marshal's office. We actually have a approved employment training platform program approved by the state to fund education for technicians to get involved in this, excuse me, underneath the builders. LAEDC, planning and zoning is relevant. I'll explain that here in just a minute as how we're going to approach the rebuild process in Los Angeles. So one of the things that we do know is that when we get a client who's in any specific area of the city that says, I want to build this way, they tend to talk to their neighbors. There's WhatsApp groups going on, there's Slack channels going on, there's all kinds of communication that we're finding is going on between the people in these communities that are trying to rebuild that are sharing information. We're going by a zone-by-zone kind of attack approach where we find one particular client, and this is an actual client that's under contract, and the neighborhood itself says, okay, we don't want wood in our community. We see it as a liability. We see it as a danger to our rebuild. So those clients tend to educate other clients with it. And so this allows us to go in and kind of do zone-by-zone marketing against it as well as production. And what I mean by that is the flat parcels, like I showed you in the prior illustration, you can produce the building elements on the actual slab itself. On the hillside properties, we're going after and utilizing land assets because there's a lot of them of burned out parcels. This allows us to set up in a particular camp and start expanding out on a zone-by-zone basis. Right now, we've got probably close to 200 clients engaged on the rebuild, which is larger than any other building system in the LA market for folks that are looking to rebuild. So kind of is part of the protocol going through just where we're at in the process. I'm not sure how many folks are local here, but I'm sure you've seen it on national news. Clearly the fire's out, the assessment's done, Corps of Engineer cleanup, I think actually went very, very well. We're working to expedite our permitting process through the building departments because it's a known minimum standard for non-combustibility. That is working well for us. The zone-based marketing I mentioned. And then what we're doing is working to sign up builders who traditionally build out of wood, who want to learn a new way and offer a new product to their clients. So in terms of losses, I don't know how much of this is discussed in national media, but we're looking at almost an equal number of homes lost between Altadena and the Pacific Palisades, and it's just a staggering number behind it. If you look at the average price of home in each market, 1.2 million in Altadena and 4.3 million in Pacific Palisades, we lost about $33 billion in assets or in damage is what happened from one fire, two fires actually in one particular time. So there's a tremendous amount of economic loss behind this. Many of the clients that we're talking to now are really in that stage of deciding whether or not they're going to rebuild, if they're going to stay, how they're going to stay there, and if they do choose to rebuild, how are they going to live in a safer environment, understanding that those risks are going to reappear at some point in the life cycle of the home. Last thing here real quick, as I'm kind of skating through this, just to show you what's happening at the state level, is understanding the politics in America right now. It's very rare to see bipartisan support for anything. This is what's called SR 61, which was a Senate resolution for the state senators, all 40 of them in the state of California, to adopt advanced building materials, particularly cement-based. You can see this was a unanimous vote by all 40 politicians that this type of technology, these types of technologies have got to become adopted in the state of California for us to survive and have a thriving home building community. This, I don't expect anyone to read, but it's a lot of the fine print in terms of just disaster acknowledgement, the fact that the disasters are going to continue, the fact that the disasters are paralyzing our home building industry, the fact that the insurance companies are running for the hills and shutting down new housing production in the state, and the subsequent result of that is that housing prices are skyrocketing. And you're losing people in the state. We're losing young people who can't afford to live here. Parents want their kids to come back after college, and the entry-level home in most communities is north of $1 million. That is all a function of lack of supply. And so if we do not change as a state to advance materials and get away from building, basically easy to destroy homes that are non-insurable, the problem at the state level is going to continue. So as virtue of that, at least in our particular business, we're pushing hard for code adoption, for mandates of products like this in high-risk fire zones. We're working directly with insurance carriers to assure that we can bring insurable products back to market. We're working to train with state funds a workforce to come in behind this thing and start really outputting a different way of building homes. And probably the most important part, at least from my perspective, is we're utilizing the current residential infrastructure. We're not setting up factories, we're not bringing in stuff out of state. Everything is produced on the job site by a trained, licensed builder. And that network on our end is growing day by day. That's my time. I'll hand it off here.
Do your thing. Well, good afternoon, everyone. My name's Joe, and I'm with Emergent. And our story really began with the Carr Fire from up in Redding, Shasta County. And in July of 2018, the Carr Fire hit the city. 230,000 acres burned, about 1,500 structures, 7 people died, including 2 children and a firefighter. And we experienced what's known now as a fire tornado. And the fire tornado actually picked up one of the fire vehicles, which the firefighter that we lost was in, and threw it about 50 yards. And he died on impact. I was in my car fleeing my neighborhood, looking in my rearview mirror at the fire tornado. And it sounds like a helicopter. It's horrifying. We're not a big community, and to experience something like that, it has a profound impact on you. Emotionally, spiritually, financially. It's really hard for a community to recover from that. So from that, Donna Jamian, who founded the company, and I'm actually the community relations guy. Donna and I have been friends for a long time. I was on the government side. I was on the board of supervisors when all this was happening. So I was part of the governmental side of the rebuild. He was part of the actual rebuild. And the consensus was we can't continue to do this. We really need to build better before these things happen, because they're going to happen. Whatever your opinion is on climate change or whatever, the reality is we have more fires and more natural disasters than we've ever had before. And we have to stop building the way we used to build. And that's really what my colleagues here have been talking about. And it takes a mindset change, which is difficult for people. Most people get very comfortable with who they are and what they're doing, and they don't want to change. Builders are the same way. They're used to building with lumber. They know how to build with lumber. They can do it quickly. They know what their costs are going to be. This is introducing a whole new world, but I can tell you from fleeing a fire, I've never been in a war zone, but I have to believe that's as close as I'll ever come to it. It's frightening, and we need to do a better job at it. So what are the benefits? Obviously, it's disaster resistant. Concrete builds are disaster resistant. Climate resilient. They're energy efficient, durable, flexible design, which I'll touch on in just a minute. Faster build times, leveraged workforce. And leveraged workforce and workforce development are near and dear to my hearts because prior to doing this, I was running a trade school. I was running the Shasta Builders Exchange and a trade school. And there's just not enough people coming into the trades. And honestly, and I'm very opinionated, we put way too much emphasis on college education. I'm not dissing college education. I have an undergraduate degree and a master's degree, but we need more people doing technical things. And we really need to encourage them to get involved in the trades because we need them. We need to live in houses. We really like running water. We like electricity. We like air conditioning. We like all those things. So this type of technology and all the technologies that have been discussed, it's attracting younger, more ambitious people into the trades because now they're using technology. I'm an old man. You know, when I first had to use an Excel spreadsheet, which was actually Lotus 123, it was mind-numbing for me. But young people grow up with technology in their hands. We're now introducing ways to design and to build using technology. I think that's a great shift. I think we're all responsible for creating the tech generation of construction workers because for every 5 that are retiring, only 2 are coming in. So I think that's something we really need to focus on. So when we were looking for a printer, it's a delivery system. Again, we're using concrete, which has been used for thousands of years. There's really no argument about the sustainability of the product. We looked at Cobot, which is from Copenhagen. It's a Denmark company. We use a gantry-style printer, just like the one you would have sitting on your desk. And we use concrete. And as you can see, that's our batch plant. So we batch on site so that we use locally sourced sand, gravel, and cement. And then we use some special products we get from Cemex to make sure that we're printing a durable, sustainable structure. One of the benefits of technology in building is you eliminate mistakes. When an individual's laying out, reading a blueprint, laying out a floor, whether he's laying out a wall for studs or a subfloor, there's possibility for mistakes. But typically the computer won't make a mistake as long as the information was put in correctly. And now we're seeing more and more architects and more engineers learning how to use this type of system. So they develop their programs so that the computer runs effectively. It really reduces mistakes, and what reducing mistakes does is it lowers costs and it increases speed. And that's just basically about 6, 7, 8, I don't know how many rows that is, maybe 3 or 4 feet of print. The way we print is it's 2 inches wide by 1.5 inches tall. And you print the entire structure just like that. And you can vary those, but we felt like that the way, given the climate and given the technology, that was the most effective way for us to print. One of the cool things, and I'll say this because I am well into the senior part of senior citizen, the design flexibility allows us to redesign homes so they're more accommodating to people who are aging in place. This is a picture of a project we're doing for Habitat for Humanity in Tuolumne County. And you can see the walls are all curved, and the benefit of that is if you're in a walker or if you're in a wheelchair, it's a lot easier to navigate that space. It's a lot more livable space. And it's a little thing you wouldn't think about, but if you're in it, you're probably really appreciating it. So the design flexibility for our type of delivery system is really cool. And as far as creativity, as is true with all the concepts you've heard, you're really only limited by your imagination, or probably more effectively by your architect's imagination. This was our Wildfire restoration house, adequately called because it came out of the wildfire. And it's a very simple home. It's 1,200 square feet, 3-bedroom, 2-bath. You can notice in the front and the back we did some curved walls just because we could. All the corners are curved. We don't do square corners because to do a square corner, the printer has to pick up, turn, and go down. It's better to just let it flow. And the key is to keep the printer running. The way we do it is we print 2 walls. There's a space in between the walls, and there's Durawall. There's all kinds of structural things that go in there depending on where we're building. We've built this model 6 times now. And I don't know if so this is actually the printer in action. And you can see it's 2 inches wide by 1.5 inches tall. And this is the first community in California that we know that was printed on site, and this is for a not-for-profit, for Access Home. So there are families coming out of hardship, domestic violence specifically, who now are occupying these homes and have a sense of community. And I think that's a real important aspect to all of the technologies you've heard here today is durability. One of the biggest problems with workforce housing and with affordable housing, especially for transitional housing, people coming out of homelessness, is landlords don't want to own them because they require so much maintenance. And if you're going for grants, you have to take responsibility for those properties for a long period of time. And at some point in time, the maintenance needed costs more than the income being generated. So this type of construction, these types of products for construction material make a big difference. And we really have to start thinking like that because we don't like to change. Again, I'm an old guy. I do not like to change. But the reality is we need to. We need to look at things differently, and starting with probably the most important investment we ever make in our lives, and that's our home. So this is one of the homes we built. And as you can see, it looks like a very conventional home. And that is by design, literally. Because we didn't want to overwhelm people with the notion of what a concrete printed home looked like. So we made it look as conventional as we could. So I'll show you a few pictures on the inside just to show that it looks like a typical home. So unless you run into the wall, you're not going to notice. If you run into the wall, if you hit the wall, you are going to notice that it's now made of concrete. But everything is just like any other house. So it isn't that dramatic a shift. It's more of a mental shift than it is an actual shift. And this is important. Again, we're a small community. The man with the scissors is the mayor. And I think Scott mentioned the importance of, I know Scott mentioned, the importance of getting government involved. The government needs to be involved. And we started with local government because we had a little bit of political influence. We got the city manager for the city of Reading to tell his building department, we will be 3D printing homes. Because no building department wants to go anywhere near this because it's new. And there isn't a lot of precedent for it. So you need to get local governments involved. We need their support. I really appreciate what Scott's doing in trying to get the state government involved because another big issue, as he mentioned, is insurance. We need to be able to build sustainable homes that insurers will underwrite. That's what crippled Paradise, because Paradise is only about 60 miles south of us. We were in Paradise right after the fire. But guess what? Nobody could rebuild because, many reasons, but the major reason was nobody would insure what they were rebuilding. So this type of technology helps impact that. Government involvement is critical. Whether you love government or don't like government, we need them to get done the things we need to get done. We're real proud of this. Again, we're a small community. Haven Humane Society, when we have a major fire, and we seem to have them all the time, the biggest problem we have is a lot of people have animals and they don't have a place to put them. So they can find a place to go live themselves, but they don't have a place to put their animals. So as a result of one of the fires, the Zog fire, Haven Humane got a grant to build an auxiliary shelter. This is a 4,000 square foot shelter. We believe it's the first animal shelter ever printed anywhere in the United States. At least that's the story we're telling. It's very cool. And this is something that's perfect for this type of structure because it's durable, it's long lasting, and it's easy to clean. Big thing here. You see the circle part? That's the amount of waste that we had. That's the amount of waste. And I know both Frank and Scott mentioned it, that's a big deal. If you look at your traditional construction site, at the end of that, I mean, I remember as a kid, a long time ago, we used to go to the construction sites, and that's where we would get all the extra material we wanted to build forts out in the woods, because that's how much waste there was. And you can see that's the amount of concrete waste, because it's sand, gravel, and cement, and whatever we don't use on this job, we just take to the next job. So with all that said, that just brings us back to where we started. We need to think differently. And I don't know what the professions are in this room, but I'm assuming there's some architects, there's some engineers, there's some people who have influence in the construction industry. We really require you to step up and start looking at influencing, and I see some very young faces in here, which is awesome, influencing the industry. Because we're talking about an industry, the greatest innovation to hit this industry was the nail gun back in the 70s. Construction isn't really known for innovation, but you've heard 3 sources of innovation that are so important, and they're so critical for this point in time. So everybody needs to take a vested interest in it. Go back to your communities. Make sure your local electeds know that this technology does, what these technologies do. Make sure they're thinking about different ways to build. That's how we're going to prevent the disasters from decimating our communities. Because there's a lot of talk about carbon and environmental damage. When 15,000, this was just 1,500 structures in Reading alone, in Shasta County burn, where does all that go? Where do the refrigerators that melted, the cars that melted, the computers, the sofas, the couches, where does all that go? It goes into our environment. It goes into our water, our air, our land. That's not acceptable. So we need to build better before the crisis strikes. And guess what? It will strike.